So hello everyone, in today's video we will talk a little about right now we are not going to solve any particular problem, but we will be talking a little about conservative and non-conservative fields. So this is a concept many aspirants really don't know this. So what's the definition of conservative field? That let's assume a force field. For example, let's assume the field F. So F is said to be, let's just write the definition, said to be conservative. Wait a minute. Okay, conservative if its work done, its work done means basically work done by the force F does not, let's go to the next line. Yes, okay, depend on the path between 2 points. So that's, I understand that this may not be a good language, but it should give you some overview. Let this, if this is a field given, and let us assume that we have 2 points. This is some, okay, so let us assume that we have 2 points A and B. Okay, so we have infinitely many paths which we can follow from A to B. We can follow the straight line one, let's say this is L. We can follow this curve, let's say it's C1. We can follow some curve like this, let's say C2. So ultimately the definition is, if F is conservative, these things should hold, that we had these two curves C1, C2. So integral, don't get confused seeing this integral. I am just writing the work done using this. So F dot dr, this is the line integral of F dot dr along the curve C1. Line integral is something you learn in complex analysis, but this much idea should be there. These mathematical terms just mean the work done along this path. So if this holds for any C1, C2, for all C1, C2 joining A and B. Okay, so in this case, then F is what? F is conservative. Okay, and we also have another thing. This was the definition. We have a whole mathematical analysis for this thing. So they won't give you to evaluate line integrals. You do not know line integrals, obviously. Probably you know a little bit, but at your level they won't give you line integrals. Okay, anyway, so for a field to be conservative, there is one thing that must hold. Okay, so I hope you know a little vector calculus, but even if you don't, then there's no problem. But this thing must hold, what I am going to write. this is said curl of f. If curl of f is equal to 0, I mean this is a vector quantity, you can see that's a cross product, so I have written 0 vector here. So if this is 0, then f is conservative, f has to be conservative. Okay, so now what is curl of f? Actually this thing nabla, if you don't know, this is actually this is an operator, and how it's defined, this is basically defined as this: I cap into del x plus j cap into del y plus k cap into del z. And now this is an operator, and now we can do operations using this, and this operation is basically cross product. So if we work this cross product out, we can have this as, I mean, let's write using the determinant form. You know this thing, right? The determinant representation for cross product. So I cap, j cap, k cap, and here for the nabla del x, del y, del z. Now usually in determinants, actually we multiplied these things, you know, determinant, but here when we have operators, we don't multiply, we operate. Now what does it mean that we operate? Let's see, we will understand in the next slide. So I mean, when we will work this out, so this is evident that there is absolutely no meaning of del y into fz. So that, I mean, that's not multiplication. We write it as del fz divided by del y minus, I mean, I am just opening the determinant now for your convenience, del fy del z. This is I cap plus what do we have for j cap? Del, wait a minute, yes, okay, del fx del z minus del fz del x into j cap plus the last component del fy del x minus del fx del y. This is the z component. So in 3 dimension, if this is the curl of f, this is the curl of f. So if, let me write now the main condition. If you if the force is given in some if in some this form, let some force be given in this form. Okay, so for this force, you may say that this force is conservative if f is conservative. Again I am writing this, when curl of f is equal to 0. And what was curl of f? This determinant, which is found to be this. Okay, and so if you write in component form, if you know fx, fy and fz, then you can write the thing as this, that we need for conservative force, for conservative, let's say conservative field, because it not only holds for force, it holds for electric field, magnetic field, and any vector field you might imagine. Okay, this is valid for everything. For conservative field, if we write component wise, then we need del fz del y is equal to, there will be three conditions for the three components, del fy by del z, let's write here del fz del x is equal to del fx del z, and finally del fx del y is equal to del fy del x. So okay, so these three conditions, these three must hold. Let me mark 1, 2, this is 3, and now just let me write the conclusion for your convenience. If these three conditions are satisfied, then the field F will be conservative. Okay, so that was the whole point of the video, that how to find if a field is conservative or not. So this is basically the thing, I mean this is basically what you have to do to find if a force field or any other field that's conservative or not. So I mean, if provided that this is the formula, it's provided that you know fx, fy and fz, the three components, I mean you know the force, then only you can work this out. Without knowing this you cannot do this, but this is the condition. And another condition is there, that's basically the definition, but actually I don't think they will ask you line integral, at least in JEE. So I mean you should not be bothered about that, but you must be bothered about these three conditions, because there may be some question about conservative forces, and actually that's highly probable, according to me at least. I mean this concept hasn't been asked in a while, so they may ask this year or next year, you never know. Anyway, so that's it for this video. I hope you learned the whole concept taught in it, and just I will wish that you have a great day, and we'll meet you in the next video. And till then, just stay tuned, and yes, again, have a good day.